Okay, so that is doing that derivative with respect to x. Questions on how I did that? Okay. All right, so just to give you a couple more examples, and I left these on here just so you can see it. D over dx of x cubed.
Where are we going?
Yeah, that's it. Yeah. So d over dx of x cubed. Does the variable on the bottom and the variable on the inside match?
Yeah.
So do I need to write any type of dx or dy afterwards? No. Derivative of x cubed, just do power rule, 3x squared. Done. Okay? The next one, d over dx of y cubed. Variables do not match. So in that case, when I take the derivative, I have to write dy dx at the end. Correct?
Mm-hmm.
Okay? The last one here, x plus 3y. So it's both an x and a y. So again, plus sign acts, remember we talked about when we first learned power rule, plus sign acts like a tube. Everything inside that tube you do independently of the next tube. So the derivative of x and x match. Derivative of x is just 1. And I don't need anything after because it matches. 3y, on the other hand, does not match. Derivative of 3y is just 3. And since the variables do not match, you have to say dy over dx at the end. Do we understand the difference there?
Good. So are these implicit?
These are implicit differentiation. Yes, you're doing the derivative of multiple variables with respect to one variable.
Okay, so we have been doing explicit.
We have been doing explicit differentiation. Yes. Okay? So, how do we do a problem like this? X times y squared. So it's multiplication. So I can't just split them into their own tubes and add or subtract. So
Product rule.
I have to do product rule. So f here is x.
We could probably reach it.
I just take my phone so I don't get distracted.
G equals y squared. So, and again, I'm doing this with respect to what variable? X. Okay, and that's important because I could do this with respect to y, and then it would end up being dx over dy. But most of the time we do this, it's dy over dx. Okay, so again, I'm doing the derivative of x with respect to x. So it's just 1. G prime, I'm doing the derivative of y squared with respect to x. So the derivative of y squared is 2y dy dx. Good.
I'm flustered.
2y dy dx. Now, remember, product rule says this. Y prime is f g prime plus g f prime.
Over G squared.
No, that's quotient rule. You don't have to divide with multiplication. With product rule.
Wait, so they're the same thing except for that.
No. Quotient rule is g f prime minus f g prime all over g squared. It's minus in the middle, and g f prime has to go first. Whereas with product rule, it doesn't really matter because multiplication order doesn't matter.
17.
Okay? So f is x. G prime is 2y dy dx plus g y squared times f prime 1 times f prime 1. So x times 2y dy dx becomes 2xy, and I just always put them alphabetically with variables, You could have yx, that's fine. dy dx. And dy dx just always goes at the end of the line. Plus y squared.
And that's your derivative?
That's one derivative.
Oh.
The only difference between this and before is now, instead of only having one variable in here, I have two.
So you just add dy dx everywhere.
You add dy dx everywhere you do the derivative of y. Only where you do the derivative of the variable that doesn't match. Because it doesn't always have to be y. Could be t, could be z, could be whatever.
T is so.
Yes.
So how come there isn't a dy dx by the?
By this?
You didn't take the derivative.
Because that one is the derivative of x. That's not the derivative of y. That's a good question. Because this y squared is just g. That's not g prime. So I'm not doing the derivative there. And that is a tricky one that some of you, as you get going and on, when you take the quiz over this, every year I have somebody, well, I remember I have to put dy dx everywhere I do the derivative of y. So in the hurry of trying to speed through it, they just put it after every y. You only put it where you're doing the derivative including y. So that y squared does not have one because it's not the derivative of y. It just is the original. Questions on that? Does that make sense?
Kind of, I comprehend it. That's a third.
I told her she was sneaky.
We already did the thing.
No, there's more things to do.
I know, but I already wrote that down.
All right.
More things to get done.
Guidelines for.
Guidelines for differentiation, implicit differentiation. So you're going to take the derivative of both sides of the equation with respect to x. When we're doing this, we are assuming it's x unless we are told something different. And we'll talk about an example of that later. 2, collect all terms involving dy dx on the left side of the equation. And anything that does not have a dy dx, you move to the right side.
After you.
Now
So-
solve for it.
If I say to solve it by implicit differentiation, like if I say solve for dy dx,
Then
I will specifically say that. Then you have to isolate and solve for dy dx. We haven't done that yet, but we will. 3, factor out dy dx, and that, again, all the dy dx's should be on the left side. So you're going to GCF, pull out dy dx, leave everything else inside the parentheses, and then solve for dy dx. So you divide by the parentheses on both sides. Okay? And I know that probably seems
Are you doing cluster?
Yeah.
more complicated than it actually is, but we'll talk through an example here. It'll make more sense.
dy dx one number, you gotta solve for dy and dx. So then
No, dy dx is one concept. That's the derivative of y with respect to x.
it's one variable.
That's one variable. So find dy dx given y cubed plus y squared minus 5y minus x squared equals 4. Negative 4. Sorry, negative 4. Not that it matters.
You didn't make these up.
No, these are straight out of your books. Okay. So we start by doing the derivative of y cubed. What's the derivative of y cubed with respect to x?
2y squared dy dx.
3y squared
3y.
dy dx. Very good.
2y dx.
So it's a power rule, and then multiply by dy dx. Derivative of y squared,
2y dy dx.
2y dy dx. Derivative of negative 5y.
Negative 5 dy dx.
Derivative of x squared.
Negative 2x.
Do I need dy dx after that one? Why? You're finding it with respect to x, so you don't need it there. Derivative of negative 4. Okay? So there's step 1. Step 2, move everything with dy dx to the left side. Well, everything with dy dx is already there.
So then we just move it
Move everything that doesn't have dy dx to the right side. And what is there that doesn't have that?
negative
Negative 2x. We're just going to add that to both sides. So if I do that, I've got 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. There's step 2 done. Step 3, factor out dy dx. Well, everything on the left side has a dy dx. I do GCF, pull the dy dx's out. Well, that means I can just get rid of dy dx on everything else. So I've got 3y squared plus 2y minus 5.
So this just be simpler if you just found the derivative of everything and left out dy dx.
Essentially. Now, wow,
So,
kind of, but not really because we're not done yet.
I know.
Now, I need to get dy dx by itself. Well, these are multiplied. Dy dx is multiplied by the parentheses. So I can just divide both sides by the parentheses.
Or maybe just simmer.
my bad.
So the answer here for dy dx is 2x over 3y squared plus 2y.
That's your answer.
That's the answer. Now,
Jared, did you just get this?
why is that
I just
helpful?
got this.
So
No.
that's saying the derivative of y with respect to x. So I could ask for the slope of a tangent line at the point 1, 2. Well, then I just plug 1 in for x, I plug 2 in for y, and that's going to give me the slope at that point on that line.
With that equation.
And that would just give me that as a numerical answer.
And that's the day.
Don't.
Just
Don't.
Try that one.
Oh, okay.
With the same guidelines?
Same guidelines, same 4-step process.
Kind of a big sigh there, Tyler. Are we doing anything tomorrow in class?
birthday and all.
Is that your family birthday?
Yeah. Get one on top and bottom?
Yeah.
No, they can't because of the plus on the bottom. If there's no plus, you could. But since there's not, you can't.
That's one.
So it is it?
How would you get it?
How would you get?
Okay, there's my derivative implicitly. Do we all agree? Okay.
Oh boy. No math.
On the road. On the road. I don't know, on the snipes.
Okay.
On the radiator.
Step 3, factor out dy dx.
Yeah.
And divide.
Trade.
Oh, I know what I did wrong. Well, I can't
All the dy dx have half in the left side, don't they?
So,
I did.
Cancel the negatives out.
Well, can I just?
Why can't I cancel
Oh,
the
exactly.
negatives?
Uh-huh.
Because of the plus sign here in the bottom. If this was minus, then you could GCF out a negative, then you could cancel.
So it'd be neg.
Now, if you do cancel the negatives, you have to make this minus in the middle.
Okay.
So if you want to cancel the negatives, you can, but that changes the bottom to 6y squared minus 4.
and now is where we stop.
Okay?
Yes. Please.
So one thing I do want to talk about, we're not going to do the last part yet.
Yet.
We'll do it. I'm saying we'll do it on Monday. But one thing that, or one place that this is used, that it is not dy dx, is if I give you a problem, and we'll do some of this with optimization. If I give you a problem and say, I want to know how the volume of a silo, let's say, to use a farming example, the volume of the silo is changing over time. So then instead of doing our derivative with respect to x, we're going to do it with respect to t. And then you will have to consider, okay, how's the x variable changing over time and how's the y variable changing over time. Okay? And that is something we will do when we start talking about maximizing area, minimizing area,
Did you have to come
maximizing profit, minimizing profit.
Did you have to come up with that example for his sister?
Yeah, we did quite a few of those, actually. Not in this section, but the next section.
I don't know, that's a thing.